$8 million a year. That is what unplanned downtime from bearing failures costs the average process plant, which works out to roughly $22,000 every single day. Now here's what's frustrating about that number. The technology to detect a failing bearing exists. Sensors exist, data exists, but there's a big difference between having a sensor on an asset and having a system that actually understands what that sensor is telling you. Because most bearing failures don't happen suddenly. They degrade over weeks, sometimes months, sending signals the entire time. The sensor was hearing, but it wasn't listening, and there is a very important difference between those two things. That difference and what it now means for your plant is what this episode is about. I'm Professor Magenta, the AI avatar of Mora Abad, Chief Operating Officer of the Reliability Leadership Institute, while Mora works alongside Terence O'Hanlon in stewarding RLI's 100-year plan to advance the Uptime Elements, the reliability and asset management framework, active at more than 6,000 locations globally. I'm the avatar she created to bring that work to you directly. Every platform we cover on this show is researched, written, and reviewed by Mora and the RLI team personally. Mora believes this work is too important to be anything but firsthand. This is Reliability AI Labs. Here is what this publication does. Each episode looks at one AI platform, honestly and independently, examining what it does, how it actually works, who it's built to serve, and where it genuinely earns its prize. Today's episode is about Tractian and the answer to the bearing nobody heard coming. Here is what we're going to cover. First, we're going to cut through something that the AI marketing in this space works very hard to obscure. The real difference between platforms that pattern match and platforms that actually learn. If you've been evaluating AI tools and they're all starting to sound the same, that section is going to give you something concrete to work with. And then make sure you stay with us through the end, because later in this episode, we're going to do something most content in this industry never does. We're going to tell you exactly where Tractian earns its prize and where it doesn't. That part of the episode is editorially locked. Tractian does not get to edit it. So if you've ever wondered whether a platform like this is actually the right fit for where your organization is right now, that answer is coming. There is a distinction in industrial AI right now that matters a great deal, and the marketing around these platforms tends to blur it rather than clarify it. So let's be direct about what the difference actually is. Some systems work by pattern matching. They watch a sensor reading, and when a number crosses a preset threshold, they fire an alert. That is useful, and it's better than nothing. But it's limited, because that threshold has no way of knowing whether the bearing it's watching is 6 months from failure or whether it's just running a little warm because the production line is running hot today. If you've ever had a platform crying wolf on alerts that your team eventually stopped trusting, you already know exactly what this limitation looks like in practice. Other systems actually learn. They've been trained on what bearing wear sounds and looks like across thousands of real machines in real plants spanning dozens of industries. When one of these systems listens to a sensor reading, it knows what it's hearing, not by comparing it against a fixed rule, but by comparing it against the operating history of every similar asset the model has ever been trained on. Tractian is the second kind of system, and the scale of what they've trained on is worth taking a moment to understand. Their machine health model has been built on 300 billion time series data points, 25 billion spectrum and waveform readings, 11 billion hours of recorded machine sound, 3 billion OEM specification files. So here is what actually happens from the moment a Tractian sensor goes onto an asset. From day one, the platform begins sampling real-time data, vibration, temperature, and sound. It takes those readings and cross-references them against the asset's OEM specifications and against the asset's own operating history over time. It filters out the noise that would otherwise bury the signal. What finally reaches the reliability engineer isn't a raw data stream, it's a signal with context attached. And critically, the platform shows its reasoning. It tells the engineer what the failure mode is, what the root cause appears to be, how far along the failure progression is, and where this asset sits in priority relative to everything else in the plan. The engineer can validate that reasoning, dig deeper into the data, or act on it directly with real confidence in what they're looking at. That last part, the explaining, is one of the harder things any AI system is being asked to do in an industrial environment. It's not enough to predict a problem. The system needs to be able to explain why it thinks there's a problem. Because a model that cannot explain itself is a model that the maintenance team will eventually stop trusting, and rightfully so. Now here is what makes that explainability possible. Inside Traction's 100,000 square foot AI center, a team of more than 200 engineers purchases real industrial machines, motors, gearboxes, pumps, compressors, servo motors, overhead cranes, and then they run them until they break. Deliberately, under fully instrumented conditions, watching every stage of degradation as it actually unfolds. A platform like this is purchased by an organization but is operated by people, and the real measure of any tool is what it changes for the people who use it every day. For the reliability engineer, the platform delivers the signal directly, with the reasoning already attached. No more hunting through raw data. Their day becomes about decisions, not discovery. For the maintenance technician out on the plant floor, the change is equally concrete. They open Traction's field AI agent on their phone right next to the asset they're looking at. They describe what they're seeing, they can share a photo. The agent walks them through the inspection process, drawing on the full history of that specific machine, understanding the current alarm condition, and adapting its guidance as the conversation develops. The technician can go from initial fault identification all the way through to a completed work order without ever leaving the asset. And then there's lubrication, because this is where a surprising number of bearing failures actually begin, and it's where Tractian does something most plants have never been able to do before. Instead of lubricating on a fixed schedule, the technician applies grease based on what the bearing is actually telling them in real time. The ultrasound reading updates as grease goes in. They stop when the bearing tells them to stop. The guesswork is gone. Once the maintenance work is complete, the platform continues monitoring the asset's recovery and confirms whether the intervention actually produced the expected result. The loop closes with evidence, not assumption. Now, in this section, and note, most industry content skips this part entirely. Let's talk about where this system actually falls short. This is the part of every Reliability AI Labs episode that the sponsor does not get to edit. This is where we talk honestly about where this platform earns its price and where it requires something more from the organization before it can deliver that value. The relevant question was never continuous process versus discrete manufacturing. It was always, which assets, if they fail, cost you most? In downtime, in quality and safety, in the hours your people spend inspecting things that don't need inspecting yet. Asset criticality is the filter. When you know what matters most, Tractian tells you what those assets are doing right now. That insight has value on a bottling line, a compressor train, and a precision machining cell. The physics of failure does not change by industry. Tractian is built for organizations that are ready to act on what their assets are telling them. The fit question isn't where a plant ranks on the maturity matrix. It's whether the people running it are willing to move. For any organization committed to knowing more and reacting less, Tractian meets them where they are. Across every implementation scenario, there is one thing that remains constant. The value this platform or any AI platform in this market can deliver is ultimately determined by the maintenance organization's willingness to actually trust what the AI is showing them and to develop the internal competency to interpret it correctly. That challenge isn't unique to Tractian. It just tends to become most visible with the platforms that are actually working well enough for it to matter. The technology in this market has gotten genuinely good. The question that determines whether any of it delivers value, including Traction's, is whether the organization on the other side of the screen is ready to meet it. If you're currently evaluating AI solutions for condition monitoring in your plant, Tractian has created a dedicated resource for Reliability AI Labs viewers that lets you see how the platform would work on your own assets. The link to that resource is in the description below this video. One more thing before you go. Every reliability leader has a gap between where their organization is and where it could be. The Uptime Elements framework was built to close that gap at any maturity level, in any industry, at any scale. It's the reliability and asset management system active at more than 6,000 locations worldwide. Start your free Reliability Nation subscription at reliabilityleadership.org. And when you get there, find a story. The reliability leadership stories are the fastest way to see this framework in action. The link is in the description. I'm Professor Magenta, and this was Reliability AI Labs. We'll see you again for the next episode. Until then, make the reliability decisions well.